So let's proceed to your third sketch. Now, as you can see on the third sketch, if you have understood the concept of when your tension forces are equal, you should be able to say clearly from the very first view of the problem that actually you can consider this one here over here, the one I'm highlighting in yellow. These are actually just the same string or cable and they are connected continuously. So wala sila naputol. They are simply connected yun over pulleys lang yun. But they are the same na string. So kana pa lang, that would be owing from that basis alone, you can say that the tensions, whatever the tension here, I'll just call that T1 and say T1 na po dapat ni, this is also T1. Okay, you should not write that as T1 and this one over here will be written as T2. This one will be written as T3. Please do not do that because of the fact that actually your tension over there are the same since they are basically, again, let's go back here, connected continuously. Wala sila naputol and they are just made from the same cable. It's just that it's just being looped over some of the pulleys that you are seeing over there, okay? And there are some free body diagrams that will help us understand that later. But then again, we have to analyze what will happen here. So as you can see from the schematic diagram over here, class, it's projected that this system will move with an acceleration A2 going downward. That mass 2 will move with acceleration A2 along with this pulley over here. And also, the mass 1 over the surface of your table will also move with an acceleration of A1. Talantawagan eh. Try to look at the free body diagram. Now, the first sketch that you are seeing here is, or your free body that you are seeing here is for mass 1. Now, if you try to look at the free body diagram of mass 1, I'm just going to highlight the tension force. The tension force is going to the right as indicated by the free body diagram as T1. Now, for mass 2, by the way, the second free body that you are seeing is for mass 2. So where is mass 2? So that is the hanging block that you are seeing over here. Now, for mass 2, the forces that exist there, okay, you have the weight, which is going downward. This one here, this is the weight, as well as the tension 2, which is pulling the object upward. So the tension 2 in that case is different from tension 1. Why? Because the cable that you are seeing here, the small cable, is not connected continuously or is not the same cable with the tension 1 above, the one highlighted in yellow. So this should rightfully be a different tension force over there. So that should be labeled appropriately as a distinct tension. Hence the notation of T2. So that's why in your free body diagram, it has a different tension force T2. Okay, now how about the third free body that you are seeing here? So this is actually the free body diagram of the pulley. Because as you can see from the schematic diagram, everything is going down here, including mass 2, as well as the pulley. Kana siya. So this is more like a proof, or not really a proof, but I'm hoping that this can help convince you that the tensions over the pulley are actually just the same. So in this case, as we have learned in our previous physics classes, so let's have the summation of forces for this one, but before that, we will have to create a free body diagram. And in this case, our body is the pulley. Now, if you try to look into this one, you already knew from the sketch that you have two forces along the y going up in the same direction, T1 and T1. Now, as I've said, if you have not realized it yet, that they are equal, you might have written that as, since we have T2, that is T3 and T4. Again, you might have written that one if you have not realized that these are connected strings and they are just basically having the same tension. So your summation of forces as well as your free body diagram should have T4 and what do you call it? T3 and T4 dapat ni. Should be T3 and T4 if you have not realized that they are the same tension. However, the correct notation for the free body diagram is to just actually have T1 and T1 in that case. Why? Because of the realization that actually they are just made of the same string connected continuously. Therefore, these two strings here, this one over here and this one over here, actually has the same tension, and hence in the free body diagram, they are just the same. T1 and T1 moving upward in the same direction. And T2 is another distinct tension. And again, I am reiterating that T2 is due to this string over here. All right. So I'm hoping this is making the point again and again that to simply ask or to simply answer the question whether the tensions are equal, we simply have to analyze whether the cable, the string, or whatever material that could elicit tension force is actually connected continuously. If it is connected continuously, then surely the tensions are just the same. Okay?